Hello. In this session, in this video, I will talk about the inverse function. We will try to define an inverse function. Then we will try to look if every function has its inverse. And then we will try to find an equation and possibly the graph of an inverse function. Okay, let's see. First of all, let's just really quickly look if we remember what function is. That's in general, we can say that function arises whenever one quantity depends on another. We have independent variable x and dependent variable y. But function is a special rule that assigns to each element x exactly one element y. X came from the domain, y came from the range. Okay, that's when we remember, it's really, really important. We do have a vertical line test. We remember vertical line test will determine if the graph, the presented graph is a function. Also, I just type just to recall that how many ways we have. I mean, we can probably create even more, but these are the ways that in general we can represent a function. We can use just the words. We can use the table with the numbers. We can have the graph, yes, visual representation, and the most common is the explicit formula, algebraically. Yes? Not always, for some real life applications, sometimes the explicit formula is not available. Then we have to look at numbers numerically or maybe the graph. Okay, now we do have two classes of function. We have algebraic function and analytic function. Analytic actually are transcendental. That means algebraic functions are the functions that we can do all of the algebraic operations on them, like in them also. Transcendentals are a little bit different. Let's actually look. Algebraic functions are like polynomials, for instance. Yes, the easiest function, linear, quadratic, cubic, and we can even increase the degree. Absolute value, piecewise defined function, and irrational functions, and in general, algebraic function, because algebraic functions are actually the ratio. I mean, could be any function, root function, but it's like, for instance, ratio of root functions. Yeah. Okay, that we can see everything. Ratio is the division. Linear, quadratic, cubic is the powers. We taking to the power, we multiplying, dividing, adding. That's algebraic. Now, the transcendental functions are the trigonometric functions, exponential and logarithmic, and you may notice inverse trigonometric, which we will investigate. Oh, we will investigate this in the next video. Okay, the inverse trigonometric functions. In this video, we will just look in general what inverse function is. Okay, that means now, really informal definition is that function and its potential inverse just undo each other. We undo the operation. And that means if our function takes x and gives us y, then the inverse function is opposite, is taking y and giving us back x. And let's see all of the functions f, and then on their functions, actually, because this is important. Yes, this will be the main question to answer. We're talking about the function and the inverse function. That's when we really have to satisfy a definition of a function. Okay, but everything still on this slide is a function. Okay, let's see. Number one, we multiply by 3. Then the inverse operation will be we will divide x by 3. Then we subtracted 3. Then we will add 3. That's the operation. That's the opposite operation. We undoing. Now we add 2. I mean, we multiply. The order is important. We multiply by 3. Yes, the independent variable. And we did add 2. Then we have to keep the order. We subtracting 2 and dividing by 3. Okay, that's important. We will have the guidelines. That means we will follow the steps. Okay, x cube. Of course, the opposite operation to cube is the cube root. Yes, we have to take cube root of both sides, for instance, if we would like to solve for x. And then similar, we have fifth root of x minus 1. That means the first operation will be, we have to take the power of 5 we have to raise to the power of 5 both sides and then add 2. And as we can see, all of the subtracting, adding, fifth root, power 5, and so on. Okay, and all of them, the corresponding inverse operation, actually all of them are the functions. So we good here. Okay, let's see. One thing, yes, let's look at this. If we know definitely that we have a function, for instance, x cubed and its inverse, cube root of x, and when we make a composition of two of those, function and its inverse, yes, that like a composition compound, we will combine them in this way. We will always result with x. Okay? That's the cancellation equation. It's the composition of a function and its inverse will result in x. And we can try. Let's see, f compound with g, okay, of x means that function f is the outer function and g of x is the inner function. Okay, that means function f is defined as a quantity x cube, but I will not put x, I will put g of x. Okay, and g of x cube, it's cube root of x, and cube root of x cube is of course x. That means whenever you will take a function and its inverse and make the composition, also the other way, we can do it. G compound with f. Let's try. Function g is outer function now, and f is the inner function. That means function g is defined as a cube root of the quantity f of x. Cube root of x cube is, of course, x. Beautiful. Okay, that means we have to just remember composition of a function and its inverse results in x. Okay, exercise number 1. Find an inverse function for the function x squared. Where is the problem? Okay, let's see. I don't know if we will have a problem, but we have to, I think we have to be careful. And let's see. And I put the steps, okay? We will still amend these steps. But for now, we know that we just undoing. That's we can write the equation of the function in this form. Now we can interchange because we basically interchanging y will become x and x will become y. Okay, now we have to solve the equation for y in terms of x. I will just change the sides and now we will take the square root because we have to solve for y. But taking the square root of both sides, square root of y squared is y, but on this side, we will end up with this equation, yes? Because algebraically, this is right. And then the resulting equation is the inverse. That means I can even say, I have to be careful. Still, let's say that the new y, that's the notation, f inverse of x equals to, but it's a big question mark because now let's see what we got. I can maybe draw this. Positive square root of x looks like this, correct? This is positive square root of x. This is x, this is y. Negative square root of x looks like this. And what we've got nice graph and it's good. However, this is not a function. Okay, that means this is not a function. Because the vertical line test, of course, will fail. For a single x, we have two outputs. That's not like a definition of the function. This was a function, okay, but doing this, like undoing this, like operations, square root, x squared, and now it's square root, we end up with the expression, with the formula that is not a function. That means the problem is, in general, for this parabola x squared doesn't have an inverse. X squared, and let's say the domain is all of the real numbers. And that means I can maybe draw here parabola x squared with domain being all of the numbers. That's when we can see this, yeah, it's an inverse, we did inverted, but we didn't get a function. That's when for now, we can say that function x squared with the domain being all of the real numbers doesn't have an inverse. And what is the problem? Yeah, that's mean which function will have an inverse and which function will not have an inverse. We probably notice, function, first of all, must have a really important feature. And the feature is called, yes, one-to-one. Function must be one-to-one in order to have its inverse. One-to-one. And when function is one-to-one, let's maybe look at the definition. Function f is called one-to-one if it never takes on the same value twice. That means for every single different x, always the output must be different. Yes? Of course, it's one output for x, but the output must be different. And for instance, when we look at the function like this, the blue function, we may use something like horizontal line test. Horizontal line will intersect the curve a couple of times, more than once, then means that function is not one-to-one, because for the x sub 1, we have value, the output is y sub 1. For the x sub 2, the value, the output is it's also the same. We can see the same value, the same height, the same level. Okay? That means this is still a function, of course, not a problem, but it's not one-to-one. Okay? But what we can do, let's maybe come back for a second to this exercise, because x squared is one of the best friends, important, nice function we're using, yes, a lot, basic, quadratic, polynomial or monomial. In order actually to still get an inverse for x squared, we may do one thing. We can restrict the domain, because for now we can see function x squared is not one-to-one. For instance, for the x2 and negative 2, the same output, because we may think that we will interchange now. Yes, that means when we have f of negative 2 is 4, f of 2 is also 4, then when we do the whole process of interchanging, we will have f of 4 and then negative 2 or 2. Yeah, we can see here 4, positive 2 or negative 2. Yes, which way we will go? That's not a function. That's the problem. Okay, that's the problem. That's what we can do. Actually, I can keep the question mark, then you will think. We may restrict the domain. We may actually force function x squared to be one-to-one. And for instance, we can say find the inverse function, yes, x squared, only for x between 0, for the positive x's, from 0 to infinity. And maybe let's include 0. Including 0, and now we can see that green part, may restrict the domain. Find an inverse function for the function x squared, and we just want x to be defined from 0 to positive infinity. We may include 0, bracket, okay? Then I don't think we have a problem, yes? Because now function, we can even draw it, okay? Function x squared is defined like this, but we're not taking the entire function. We're just taking that part, okay? And now, since we interchanging, because this is domain, and then a range for this function is also, we can see y values are also positive from 0 to infinity, okay? And now, since we interchanging x and y, we also interchanging domain and range. That's when we know the formula. That means this is still the same formula. The inverse function, it's square root of x, and we can say x and y, actually they are the same. That means it's easy. We can only take that part. Okay, we remember, let's come back, we can see, because this part is defined for the positive x's and positive y's. We cannot take negative because that's not the domain. Because now domain, okay, for this, I mean, they will just interchange. They will just interchange. I can show you because I don't want to confuse x and y's. That means this is an inverse. Okay, inverse function for x squared will be square root of x, but we're just talking about these restrictions. And then it's perfectly fine. This is a function, square root of x is a function. We will not take the other part. Okay, that means please remember that if we are asked to find the inverse, we always have to check if the function is one-to-one. If it's not, we may restrict the domain. Okay, we good? Actually, before I show you the final definition, let's check, yes, determine whether this function is one-to-one. Sine of x, what do you think? Is function sine of x one-to-one? We know that it's not. We can even see sine function is a beautiful curve which takes the same value infinitely many, some of the, values infinitely many times. Pi over 2, 5 pi over 2, and then another one. Let's say that's the value 1. Okay, this is 3 pi over 2. The value is negative 1. Okay, negative pi over 2. The value is negative 1. That means when we will draw a vertical, horizontal line, we can see that value 1, for instance, yes, value 1, it will happen infinitely many times for different x's. That means f of pi over 2, or actually I can say function sine at pi over 2 is the same, let's just, as sine of different x, 5 pi over 2. Okay? It's exactly the same. The value is 1. But the x's are different. That means for different x's, we have the same output. This is still a function, vertical line test, but it's not one-to-one. That means function sine of x is not one-to-one. Now, let me just quickly, because before the video of the inverse trigonometry, because we do have, it's a big important section, inverse of the trigonometric functions. That means sine of x is one of them. In order to actually get the inverse, what we will do? Yes, you're probably thinking correct. We will restrict the domain. Okay, that means for the sine function, we will take that small part. Okay, that's we will just take the function sine of x, but the domain is between negative pi over 2 and positive pi over 2. Range, still the same, from negative 1 to 1. And this part is 1 to 1. Okay, we will talk about this again at the next video, but we can see with this restriction, now getting an inverse, we will interchange x and y's, respectively, we will interchange the domain. This will become domain, this will become range, and then we will go from there. Okay, that means one more time, in general, sine of x is not one-to-one, but when we restrict the domain, it is that we will just take that blue part, that small part. Okay, now let's look at the definitions and do a couple of questions and we will be done. Okay, that's mean general definition, the formal definition of the inverse function. Let f be a one-to-one function with the domain x and the range y, then its inverse function, which is denoted by f like inverse, yeah, please do not mistake this with the exponent like -1. Unfortunately, that's the notation, has domain y and range x, yes, we interchange it, and we will just write this way. F inverse of y equals to x, then f of x equals to y, for any y from y. Okay, that's the cancellation equations. Yeah, that's the other words. And we can say that function f has an inverse. Yeah? Then we can call it's invertible. Yes, a function f, when the function f has its inverse, it's invertible. And the same thing, the thing that we just mentioned, domain of the inverse is the range of the function, range of the inverse is the domain. And that note, yes, please do not mistake this with the exponent. F inverse of x doesn't mean the reciprocal. It's just the notation for the inverse. Okay, now like the guidelines, how we can find inverse function. First of all, we have to determine if the function is one-to-one. If it's not, we will restrict the domain. Then we will write an equation, interchange x and y's, domain and range, solve for the new y, yes, in terms of x, and the resulting y is an inverse. Also, is interesting thing, if we will be able to put function and its inverse, the graph, in one xy plane, they will be symmetric with respect the line y equals to x. Of course, we have to be again really careful because we're interchanging x and y. That means drawing actually a function and its inverse in y in one xy plane is a little bit confusing sometimes. But if we can make this, the graph will take the graphs inverse and function and its inverse will be it will be they will be symmetric with respect to the y equals to x. Okay? Now let's see. Let's actually find an inverse finally. Find an inverse function for f of x equals to square root of x plus 1. Find the domain range of both function and its inverse. Okay, that means I can maybe check if this function is one-to-one. Yeah? And based on the graph, because we know the fundamental function square root of x, we know how this looks like, plus 1 means that we just going 1 unit to the left. That means this is graph square root of x plus 1, and yeah, this will be also 1, and it's definitely 1-to-1. Yes, no problem. Okay, that means function is 1-to-1. Let's actually state the domain. Domain of the function is from -1 to infinity. And range, we can see function is just placed above the x-axis because it is defined as a positive square root, never negative. Okay, and then we will interchange. Okay, inverse. Let's find. This is the formula. We interchanging. This becomes x, this becomes y. Okay, let's take this, let's square both sides, and then y equals to x squared minus 1. But what is important, and this is the inverse, I can say inverse function, but domain will be just positive numbers. Yeah, I have to interchange those. And range will be defined from -1 to infinity. That means, let's see, because if we will draw x squared minus 1, it's parabola x squared shifted 1 units down. Yeah, that's not exactly true. Yes, not exactly true. We have to just take part on positive axis. That means this is positive axis, and that makes sense. That means this is function, okay, and this is inverse. And if we will draw them in one xy plane, they will be symmetric with respect to y equals to x. Okay? Okay, but please, that's the reason we have to keep it. We have to interchange domain and range. That means this is that's the graph. It's x squared minus 1, but not the entire parabola. Okay. Ooh, another one. What we can try maybe to check if this function is 1-to-1, but we can see it's a rational function, and it is, yes, it is 1-to-1. How we can draw this function? This function is one-to-one, but I just wanted to maybe draw this function. Okay, 2x minus 1, x plus 4. We definitely know the basic rational function, 1 over x. Hyperbola in the first and the third quadrant. We can see we have horizontal asymptote 0 and the vertical asymptote 0. Now, this function has lots of transformation. We have to check when is the x-intercept. I mean, this one doesn't have x-intercept. I mean, when is the horizontal, when is the vertical, because it's just like 1 over x. But we have to find the vertical and horizontal asymptote. Horizontal asymptote, actually, no, let's see. We have to, what we can do? We have a couple of ways. We may do algebraically. Okay, that's me. I'm still not looking for the inverse. I'm just trying to get the graph. That's we can divide this polynomial by this long division, but let's just do different. I will just put this because that's 2. And this is 2x plus 8, because 2 times 4 is 8. And we had minus 1. That means plus 8 minus 9 is negative 1. I didn't change anything, but I just use, okay, that will be good way. Okay, this one is cancel out. Okay, that's, we can see 2. We're shifting the horizontal asymptote 0, we're shifting to 2. And then it's negative 9 over x plus 4. That means domain for this is all of the numbers, but not negative 4. Yes, all of the numbers, but not negative 4. Range are all of the numbers, but not 2. Because we can see this value will be never 2, because this value is never 0. And since we're shifting, because it's plus 2, we're shifting 2 units up. Okay, that's me. Let's see. Not negative. Since this function is not defined at negative 4, we will have an asymptote, because that vertical asymptote is shifted 4 units. And plus 2 means that we're shifting horizontal asymptote 2. And we will not draw in the first quadrant and the third quadrant, no, because we have negative. Yeah, this is just transformation. That means we will draw a function in the opposite. I could say second and fourth. Oh, not touching. Okay, this is x-intercept, 1/2. We can see, because if the x-intercept is when the y is 0. As we can check. Oh, we're actually doing 2x minus 1 over x plus 4 equals to 0. Fraction equals to 0 if the numerator equals to 0. Okay, perfect. And this value, y-intercept, is 2x minus 1, x plus 4, if x is 0. Negative 1/4. Negative 1/4. Okay. We have the graph. Okay, it's definitely 1-to-1, but we can see no x's at net negative 4 and y is not defined at 2. Okay, let me erase this. Yeah, make sure that you know how to use the transformation. And now we need the inverse. I can maybe use different color. That means let's find the formula. I will take this and interchange. Okay, x and then 2y minus 1, y plus 4. Let's solve for y. Multiplying both sides by y plus 4, 2y minus 1, distributing x, xy, 4x, and then xy, 4x, subtracting 2y and adding 1, and then factoring out y. x minus 2, and subtracting 1 and subtracting 4x. Okay, and now negative 1, negative 4x, divide by x minus 2. Let's factor out negative and apply the negative in the denominator. Then we're switching the sign. Beautiful. This is an inverse function. 1 plus 4x over 2 minus x. And we can see right away, domain is all of the numbers, but not 2. Yeah, we're interchanging. Range, all of the y's, but not negative 4. Not negative 4, because again, 4 and negative, when I do the same, yes, the same steps, we will end up with that. Okay, that's definitely an inverse, and we may try to draw, that inverse. Where we can draw. I will not put at the same xy plane. Okay, that's what we have. X is not 2. That means we will have, instead of the horizontal asymptote, now we have a vertical asymptote at 2. We had a vertical asymptote at negative 4. Now it will be the horizontal asymptote at negative 4. Okay, beautiful. And then it's the same. We will have negative. That's when we will draw a function here and here. Right? Of course, we need a little bit of maybe calculus to check this, but we know based on the transformation. And now let's see if they interchange. X-intercept was 1/2. Now this will be 1/2. Yes, when we put 0, 0, it's 1/2. The y-intercept. And now, I did erase. And the x-intercept, where am I? Y-intercept was negative 1/4, and now this one will be, everything is exchange. Yes, we interchange. Okay, and these graphs are definitely symmetric with respect y equals to x, if we will put them in the y and xy plane. Okay, that means try to solve for exercise. Yes, try to make sure that we know all of the formulas, but the important part is function must be one-to-one. Okay, in order to get the inverse. That means if function is one-to-one, has the inverse. Domain and range exchange, everything exchange. We even see horizontal, vertical asymptotes, x and y intercept, and they are symmetric with that line. Okay, thank you. And the next video about the inverse function will be the inverse trigonometric functions. Thank you.